Flippin' Physics.
Good morning, everybody. It is lovely to have you here for my Unit 2 AP Physics 1 live Kahoot multiple choice quiz. If I could just give some sort of confirmation in the chat that everything's working, you can hear stuff and see the video and everything, that'd be lovely. Hi. I guess I'll start with, well, actually, here, you guys could start signing up for the Kahoot clearly, and you're doing that. Perfect. So please sign up for the Kahoot. Before I get started, I just do want to say I am sorry about last Tuesday. I was in the emergency department at 7 o'clock. 48 hours ago, I was actually getting a CT scan and was diagnosed with a kidney stone. So yeah, I was not in any way, shape, or form able to do this. Yeah, that's my fault. I brought the echoing. It should fix itself in a second there. Yeah, so sorry that I could not do this. I was in a horrendous amount of pain. So I'm glad to be able to be here today, doing this for you today. So here we go. So Unit 3 will be on Tuesday, December 16 at 7 p.m. Eastern Time, assuming, of course, I'm not in the emergency room again. And I just do want to take a moment to say that Unit 2 has a very large number of topics in it. Sure. Are you okay? I will answer that real quick. I am still in pain. I'm on pain meds. And I don't know if you know how kidney stones work, but this kidney stone is working its way through my system, which is painful. And then the ejection of the kidney stone is also very painful, but I'm not to that point. But hopefully I will soon. But right now, I'm okay. Yeah, I'm okay. It's just pain. I'll be okay. So I was saying Unit 2 has a plethora of topics in it. So I understand that some of you, a lot of physics teachers teach things in different orders and may not cover all of Unit 2 all at once. So there might be a question or two in here that it goes over a topic that you haven't learned yet, but it will still be useful for you even if you have not completed Unit 2, all of Unit 2 with your class. Thank you for the Get Better Well Soon. I'm going to do my best. All right. So Section 1 of the AP Physics exams have 40 multiple choice questions in 80 minutes. So that's 2 minutes per multiple choice question. And so that's what we're going to do today. So every multiple choice question you're going to see in the Kahoot, you're going to have 2 minutes to work your way through. So please say hello to our moderator, Miss Bonk. She is there to hopefully answer any tech questions that you have and just help out in any way that she can. She is an AP Physics teacher and Project Lead the Way teacher at Addison Trail High School, which is a suburb just west of Chicago, I believe. I do have to say that I do have my Ultimate Exam Slayer and Ultimate Review Packet. The Ultimate Exam Slayer, this is the first, you're going to see the first 10 multiple choice questions for AP Physics Unit 2. And then you'll see the second, or there are another 15 multiple choice questions that are in the Ultimate Exam Slayer. And I also have my Ultimate Review Packet. The Ultimate Exam Slayer is specifically tailored to understanding the exam and going through how to understand the exam itself, whereas the Ultimate Review Packet is designed to help you understand the material a little bit better. Ultimate Exam Slayer has 2 practice exams, and the Ultimate Review Packet has 1 practice AP Physics 1 exam. And you can take it in we have a digital exam simulator, and it's really helpful. So, all right, looks like we're pretty close. We still have a couple people coming in. All right. Well, I think I'm going to get started. So what I need to do, give me a second. I have to adjust the way the screens are set up in order to get started. So give me just a moment. So here we go. Let's do this actually. Perfect. All right. So then this one goes there. And this one goes here. Let me just check real quick. All right, so I got that one. Boop, boop, boop. Go back here, play. All right, and then we have, actually, let's go like this. Perfect. All right, so sorry, I'm just adjusting the way everything's set up here. Okay, so I think we're gonna get started with the first question here because we're 5 minutes past, and so it's time to get started. So we have our first question, and I will press start. I guess you'll have a little bit more than 2 minutes here because it does do our little thing, but that'll be okay. All right. So choice D is the correct answer. And let's come back here and let's take a look at why that is. So hold up. Did I get this wrong? Oh, bummer. Okay, give me a second. I got to adjust this. This one here. There we go. And then, sorry, it's not set up right. Bonk. There we go. All right. And then this one, hold up. I got this one and this one and this one. Perfect. So this goes there. All right. Sorry about that. Okay. So we have our first question here, and all right. So this question is a typical ranking values type of multiple choice problem where they've got your comparing the magnitudes of the accelerations. You're going to see this ranking values type of multiple choice problem probably a couple times on the AP exam. So in this particular problem, we know that Newton's second law is that net force equals mass times acceleration, where both force and acceleration are vectors. So they are identical boxes, so they have identical masses. So box 1 has no forces in the y direction, so the net force is only in the x direction. All we have to do is sum the forces on box 1 in the x direction. And you get negative 10 to the left, because it's negative because it's to the left, 7.5 newtons positive because it's to the right. So the net force on box 1 is negative 2.5 newtons, so it has a magnitude of 2.5 newtons. So looking at box 2, we need to break this 15 Newton force into its components. You could see there's got a 30-degree angle here. So we've got the force in the y direction, force in the x direction. The hypotenuse is the 15 newtons. So sine theta equals the opposite of hypotenuse, or sine of 30 degrees equals the force in the x direction divided by the hypotenuse, which is 15 newtons. So we could solve for the force in the x direction, which is 15 newtons, times a sine of 30 degrees. So that's breaking that 15 Newton force into its components. In the x direction, it's 7.5 newtons. So then the net force on box 2 in the x direction is negative 7.5 because it's to the left, plus 5, or negative 2.5 newtons. So class, are we done? And anytime I ask this question, class, I'm actually asking you, and I want you to put something in the comment. Are we done? Did we just determine that the magnitude of the net force on box 2 is also 2.5 newtons, and therefore the accelerations on boxes 1 and 2 are equal in magnitude, and therefore the correct answer must be A, because that is the only one that has boxes A and boxes 1 and 2 with the acceleration being equal. So I'll answer this question. This video will just be after it's live. It's just going to stay here and everybody will be able to see it afterwards. So it's just going to be there. Right. So class, are we done? Did we just figure it out? Right. There is a y component. All we did on box 2 is figure out that the x component for box 2 is the same as the net force for box 1, but box 2 still has that y component. So please realize that you have to be careful of this. And be careful of moving too quickly and making rash decisions on the AP exams. You're going to feel compelled to just move really quickly, and you need to learn what an appropriate pace is. And you need to practice, and I of course have those practice AP exams. So, but just realize, no, you want to slow down and not make silly mistakes like that. So we're still working on box 2. So we figured out that the net force in the x direction on box 2 is negative 2.5 newtons, but we can also use the cosine of theta equals adjacent over hypotenuse to determine the force in the y direction, which we can get to be 15 newtons times this cosine of 30 degrees, or 12.99 newtons. So real quick, I got this question. So can you explain what a y component is? Okay, so this 15 Newton force, which is this force right here, we can break into its components in the x direction and the y direction. In other words, when you add the force in the y direction to the force in the x direction, these two components of this 15 Newton force, they add up to this 15 Newton force. So that's what it means to be the components of a force. When you add those two vector forces together, you get this 15 newtons at an angle of 30 degrees to the left of the vertical. So that's what it means to be a component of a force. All right, so we now know that the net force on 2 in the y direction is 12.99 newtons, because that's the only force in the y direction. So then we can use the Pythagorean theorem to determine the net force, because we now know the net force on box 2 in the y direction and the net force on box 2 in the x direction. We can figure out the net force on box 2. So it just ends up being equal to the net force on box 2, just equals the square root of the net force on box 2 in the x direction squared plus the net force on box 2 in the y direction squared, or the negative 2.9 squared plus 12.99 squared. And please realize that negative is in the parentheses and does end up being squared as well, which makes that a positive number. So we end up with 13.228 newtons for the net force on box 2. right? That's the magnitude of the net force on box 2. So now we know the magnitudes of the net forces on box 1 and box 2. We need to look at box 3. Again, we need to resolve the 15 Newton force into its components, but notice it's at a 45-degree angle instead of a 30-degree angle. So we now have our components here, and you should recognize that the sine of 45 degrees and the cosine of 45 degrees are equal to one another. Therefore, we could just use sine or cosine, so it doesn't really matter. We end up with the sine of 45 degrees equals the force in the x direction divided by 15 newtons. So we have the force in the x direction and the force in the y direction are both equal to 15 newtons times the sine of 45 degrees, or 10.607 newtons. So in the x direction, we have to the left 10.607 newtons, or negative, plus the 7.5 newtons right here. So the net force in the x direction is negative 3.107 newtons, and the net force in the y direction is just this 10.607 newtons, that force in the y direction. So again, we're going to use the exact same concept here of using the Pythagorean theorem. The net force in the x direction then is just going to be equal to the square root of the net force in the, the net force magnitude of the whole net force is going to be equal to the square root of the net force in the x direction squared plus the net force in the y direction squared. And we get 11.053 newtons for the magnitude of the net force on box 3. So at this point, we've identified that the net force on box 1 is less than the net force on box 3, which is less than the net force on box 2. And therefore, the correct answer is D, because the magnitude of the acceleration of 1 is less than the magnitude of the acceleration of 3, which is less than the acceleration. Great. This is a great question. I'm going to come back to this. I will answer this question. What's the best way to do this in 2 minutes? I will answer that question. So, should you expect a multiple choice problem on the AP Physics 1 exam to be this mathematically complicated? The answer is probably not. So I actually did this on purpose. I gave you a problem that I would consider to be too difficult for a single multiple choice problem on an AP exam. If this were on the AP exam, this is still very useful for you to understand because it really helps you, walking through all the math really helps you to understand how all this works. But a problem like this on the AP Physics 1 exam would probably be able to be solved visually. I specifically set this up so that you couldn't tell looking at these two which one would have a larger magnitude net force. But on the AP exam, I would expect that you would visually be able to tell. So that's my answer to your question. I don't expect you to be able to do this one in under 2 minutes. I really don't. I probably shouldn't have started there, but I did. All right. So let's see. So that's my best guess, of course. I don't know exactly how they're going to work out the AP exams. All right. Question 2. So we need to move on to question 2. Let's see how people are doing. Let's see. We have Invisible Scorpion in the lead. Beautiful. All right. Moving on to question 2. All right. Looks like a lot of people got choice D is correct. Let's that's awesome. So before we walk through my solution for question 2, let's address a couple questions people had here. All right. So are there basic notes I can write down for this question? I'm going to answer that, as well as is there a place to get these slides and questions? It's basically the same thing. So realize in my ultimate exam slayer, I have all of these questions, and in the ultimate exam slayer, I have also identified. You will see not when you click show answer, it shows not just the answer, but a whole description. And the whole description that is there is what I'm walking through in these slides. So in my ultimate exam slayer, you get all the questions and you get all the solutions and everything I'm talking about in these slides here, and you get 15 more questions for each unit. All right. So question 2. One thing I need you to understand about question 2 is there are a lot of words, and there will be problems on the AP Physics exams with a lot of words. It's something you need to get used to. Sadly, they're just going to be a lot of words sometimes. Okay, this is a classic Newton's third law question. The force from the truck on the object is equal to the negative of the force the object exerts on the truck, right? This is an equal in magnitude but opposite in direction forces. So when we're talking about the magnitude of the force of the truck from the truck on the object and the magnitude of the force from the object on the truck, those are going to be equal in magnitude. So you should hopefully you can recognize questions like this. This is a Newton's third law question. So the magnitude of the force the truck exerts on the object is the same for in each instance. So therefore, the magnitude of the force each object exerts on the truck is the same in each instance. Again, this is a Newton's third law question. I can almost guarantee you there's going to be one like this on the AP exam somewhere. So the correct answer is D. Now, the acceleration of the truck is different each time, but that does not mean that the force the object exerts on the truck is different each time. It means that the net force on the truck is different each time, not the force that the object exerts on the truck. I did get a question, is there friction? It is irrelevant as far as this question is concerned. That'll only affect the net force on the truck. That won't affect the force the object exerts on the truck. So yes, this is a conceptual understanding question as opposed to a skills or a mathematical question. And there will be a good balance of conceptual understanding versus like mathematical skills. And this is an example of a conceptual understanding one, whereas the previous one was really more mathematical skills. All right, question 3. Actually, let's see how we're doing. Oh, Decisive Unicorn is in the lead. All right, let's move on from question 2 to question 3. All right, here we go. Come on, there we go. Okay, perfect. Yeah, that's probably good enough. That's good. All right, here we go. Choice A is the correct answer. So let's look at this question. All right, so we have question 3. The box is moving at a constant velocity. Therefore, the net force on the box is equal to what, class? That's a question. Looking for comments in the chat. The box is moving at a constant velocity. Therefore, the net force on the box is equal to what? Correct. The net force is equal to 0. All the forces balance out. So you got to be able to identify things like this. It says a box on a horizontal surface is moving to the right at a constant velocity. So constant velocity in the x direction, it's not moving at all in the y direction. So the acceleration is equal to 0. If the acceleration is equal to 0, the net force is equal to 0. Therefore, you are looking for a free body diagram which has a net force equal to 0. So the only free body diagram which has a net force in the x and y directions which is equal to 0 is choice A. So notice in choice B, the net force in the y direction is up. Yes, these two forces balance out, but this has a component in the y direction which makes it so that the net force in the y direction, or the forces in the y direction exceed the forces the net forces in the positive y direction exceed the net forces in the negative y direction. Therefore, the net force is up. And the net force in the x direction is to the right because the component of this one is larger than this force to the left there. Choice C, again, the net force is in the y direction is up. The net force in the x direction is equal to 0 because this component is equal to this component. So the net force in the x direction for C balance out, but not in the y direction. And then for choice, I believe that should say choice D, the net force in the y direction is 0. The component here and the component here add up to the same value as that component. Hold up, I want to come on. So choice B, or sorry, it's just choice D. So it should say choice D is also incorrect. The net force does not equal 0. But let's just look at this first one just to make sure we understand why the net force adds up to 0 here. So the force in the free body diagram look like this. The force of tension is to the right and 30 degrees above the horizontal. The force of gravity is straight down by definition. The force normal is up and perpendicular to the surface and a push, so that is going to be straight up. And the force of kinetic friction is to the left because the box is sliding to the right relative to the surface. We need to resolve the force of tension into its components. We don't have any numbers, but we can visualize it. You can see that the force in the y direction is 2 grid spaces up, and the force of tension in the x direction is 4 grid spaces to the right. So we can redraw the free body diagram with the components, and you can see the net force in the y direction, or sorry, in the x direction, this component balances out that component. And then in the y direction, if we add the force normal and the force of tension in the y direction, that has the same magnitude as the force of gravity. Therefore, the net force is equal to 0. So again, choice A is the only choice with a net force equal to 0. Choice A is correct. Why wasn't it C again? Well, the net force in the y direction for C is up because this component here of this force is 2 boxes, grid lengths, if you will, plus the 5 or 6 here, I guess, and that's going to be greater. So yeah, perfect. All right, let's move on to question. Oh, wait, we need to see how people did on question 3. Oh, decisive unicorn, still in the lead. We will see if you can keep a hold of that. All right, moving from question 3. Okay, sure, we'll answer this question because this is actually important. So how do we get the exact magnitude of the x and y components for the force of tension in A? So the way you get that is from the grid. So this grid, you're going to count the boxes. These grids are, since the exam, the changes to the AP exams for the 2025 exam, all the free body diagrams where you're going to need to compare magnitudes are going to have these boxes. So you can count the number of boxes if you're going to be doing it visually. Just so you know. Okay. All right, we're moving from question 3 to question 4. All right, choice B is the correct answer. Let's walk through why that is. All right, so we are on question 4. Let's move on to question 4 here. All right, so let's see. Question 4. The velocity of the center of mass of a system is not on the equation sheet, but the position equation is. So the position equation for the position of the center of mass is the sum of the mass times position for each object divided by the total mass. So for this particular case, because we have 2 objects, cart Q and cart P, that would be the mass of Q times the position of Q plus the mass of P times the position of P divided by the sum of the masses. But realize that you could replace this position with velocity. You can also replace it with acceleration if you're looking for the acceleration of the center of mass. So from the equation sheet, you can get from this position of the center of mass of a system of objects to the velocity of the center of mass of the system of objects. So to find the velocity of the center of mass of this 2-object system, we're going to take the mass of cart Q times the velocity of Q at 2 seconds, plus the mass of P times the velocity of P at 2 seconds, divided by the total mass of the 2 objects. So the two carts are identical, so they have the same mass. So let's just identify that as capital M. We could substitute in capital M for both of these, and you could see for both of the masses, and you could see the masses cancel out, and we end up with the velocity of cart Q plus the velocity of cart P divided by 2. So in order to solve for the velocity of center of mass of this object, all we have to do now is determine the magnitude of the velocity of each cart at 2 seconds. All right. So class, where do we find velocity on a position versus time graph? It's a question for you. Looking for an answer in the chat. I don't believe graphs have tan lines because they don't go out in the sun. We're not in AP Physics C with calculus, so we're not going to say the derivative. We're going to say what the derivative actually is. We're also not going to put d slash d dx because that's, again, calculus and right. Where do we find velocity in a position versus time graph? Steepness of the graph is an interesting one. I'll talk about that when we get to the right answer. That's close. Delta x over delta t. Again, that would be the equation for velocity. We're looking for, where do you find the velocity on a position versus time graph? Tan line is close, but even if you call it tangent line, it's still not right. Because tangent line is just saying what a line is. Sorry, I am very specific about what I'm looking for. Where do we find velocity on a position versus time graph? X over t. We're getting close, but no. X over t. Ah. Just so you know, I've made it so you have to wait a minute between leaving a comment, which means that everybody has to be involved. So again, we have the change in x over change in time is not quite right. So we're looking for, where do we find velocity in a position versus time graph? I'm really interested. This is okay. So saying the instantaneous velocity is x over t at 2 seconds. There is no x over t at 2 seconds. Thank you, Miss Bonk. Okay, so here we go. We're very close. The problem is that you have so many answers that are very close. The slope of the tangent line at the point. So if we're looking for the velocity at 2 seconds, we're looking for the slope of the tangent line at 2 seconds. Again, you can't just say tangent line. You cannot just say derivative. You cannot just say slope. You cannot just say position over time. You cannot say change in x over change in time. None of those are the slope of the tangent line at a particular position. So please just realize there's a lot that goes into this. You have to be very, very clear. And you're going to have to be able to answer questions like this on the free response questions and to be able to answer it correctly with using all the right words. That's why I'm very careful to walk through all of this. I know it's annoying. Trust me, I'm a teacher and I know it is annoying. Okay, here we go. So the slope of a position versus time graph represents velocity. The slope of cart Q's position versus time graph is constant. So when we look at cart Q, this blue line, that has a constant slope. So that one we can simply use the equation for constant velocity, because a constant slope on a position versus time graph represents a constant velocity. So just to figure that out, all we need is the position of Q at 3 seconds minus the position of Q at 0 seconds divided by the time of Q at 3 seconds minus time of Q at 0 seconds. or 3 meters minus 0 meters. So that's this point right here. Or I'm sorry, 3 meters minus 0 meters over 3 seconds minus 0 seconds. So we end up with 1 meters per second. So that is the velocity of Q at 2 seconds. Is the velocity of Q the whole time, but it is also the velocity of Q2 at 2 seconds. So just to review the answer to the question, where do we find velocity in a position versus time graph? It is the slope of a position versus time graph that represents velocity. It's going to make more sense when we walk through the velocity of P at 2 seconds, because the slope of cart P's position versus time graph is not constant. So we need to draw a tangent line to cart P's curve at 2 seconds and determine the slope of that line to determine the magnitude of the velocity of cart P at 2 seconds. So you can see, I'll try to zoom in a little bit. You can see here, cart P at 2 seconds. I've drawn this tangent line in a dotted line as the tangent line. And in order to figure out the slope of this line, we have to identify 2 points. So I picked this point right here and this point right here. This point right here is at 3 seconds and 5 meters. And this point right here is at 1 second and 0 meters. So to figure out the slope of this tangent line, we have the change in y over change in x. The 5 meters minus 0 meters, that's going to be what's on the vertical axis, divided by what's on the horizontal axis, the change in, so 3 seconds minus 1 second. So the slope of cart P at 2 seconds is 2.5 meters per second, and that represents the instantaneous velocity of cart P at 2 seconds. Remember, our goal here is to figure out the velocity of the center of mass of the 2-cart system, and we figured out an equation for that. It is the velocity of Q plus the velocity of P divided by 2. So 1 meter per second plus 2.5 meters per second, all divided by 2, or 1.75 meters per second. So the correct answer is B. Now, what's fun about this is I do want to point out, actually, let's do this. So it does say which of the following best estimates the magnitude of the velocity. Notice our answer is 1.7 meters per second. That's the one that is closest. We got 1.75. And it's not guaranteed when you draw this tangent line that you are going to get exactly the same numbers that we got. But you are going to get something that is close to 1.7. So when it does ask this question, which of the following best estimates, like which one is the closest to, you might end up getting an answer that isn't exactly the same as the answer given in the problem, but you'll get something that is very close. So in this particular case, we got 1.75, which technically rounds to 1.8 meters per second, but the closest answer is choice B at 1.7 meters per second. Beautiful. We are done with question 4. Let's see how everybody did on question 4. Oh, Decisive Unicorn still leading the pack. Moving from question 4 to question 5. Beautiful. Next. Nope, I forgot to press that, or I didn't hit it. There we go. All right, look at that. I like it. We got a lot of people getting the right answer. Choice A. Okay, here we go. Question 5. Okay, in question 5, the block is moving relative to the surface in both cases. Therefore, the force of friction is kinetic in both cases. The force of kinetic friction equals the coefficient of kinetic friction times force normal. And we know the coefficient of kinetic friction is constant between the two cases. So all we're looking for is the force normal, trying to compare the magnitudes of the force normal. So that's it. All we have to do is compare the force normals. So we need to draw free body diagrams. For case 1, we got force normal 1 and force of gravity, force of tension, and force of kinetic friction 1, right? Force of tension is to the right, force of kinetic friction is to the left because the block is sliding to the left relative to the surface. Force of gravity is down. By definition, the force normal is perpendicular to the surface and they push, therefore it is up. In this particular case, we can sum the forces in case 1. In the y direction, we get force normal 1 minus force of gravity equals mass times acceleration in the y direction. The acceleration in the y direction is 0 because it's not moving in the y direction. Therefore, we get the force normal 1 is equal to the force of gravity. So we have determined that we know force normal 1 equals in magnitude to the force of gravity. We can sum the forces in the x direction. We get force of tension minus the force of kinetic friction. In case 1 is equal to mass times the acceleration in the x direction. So force of kinetic friction in case 1 is equal to the force of tension minus the acceleration in the x direction. Great. We know the acceleration in the x direction is greater than 0. Therefore, the force of kinetic friction in case 1 is less than the force of tension. Beautiful. For case 2. Now, the same magnitude force is up at an angle. So we have the force of gravity, which is unchanged, but this force of tension, which is the magnitude of the same, but it's now directed up at an angle of 30 degrees. Force normal is still up, but we do not know its magnitude. So notice I put unknown magnitudes here. I don't know yet the magnitude of this force normal 2. The force of kinetic friction is still to the left, and again, its magnitude is unknown, and that's what we're solving for at this point. We need to resolve the force of tension into its components. So notice we're doing this again, breaking this force of tension into its components. Again, we did parts of this solution before, so let's draw the free body diagram. We've got the force of tension in the y direction, force normal 2. We can redraw that free body diagram. So now, in case 2, we have the sum of the forces in the y direction, force normal 2, plus the force of tension in the y direction. Those are vertical upward forces, and the force of gravity, which is down. Again, the acceleration in the y direction is equal to 0. Therefore, we get that the force normal 2 is equal to the force of gravity minus force of tension 1. This force normal 2 is equal to this force of gravity minus this force of tension in the y direction. Now, we figured out before that the force of gravity was equal to force normal 1, so we could substitute force normal 1 in for the force of gravity, and we now have determined that force normal 2 is less in magnitude than force normal 1. That is why you can see I've decreased the size of force normal 2. And therefore, we know because force of kinetic friction 1 equals the coefficient of kinetic friction times force normal 1, and the force of kinetic friction 2 equals the coefficient of kinetic friction times force normal 2, that because force normal 2 is less than force normal 1, and the coefficient of kinetic friction is the same in both cases, that force of kinetic friction 2 is less than the force of kinetic friction 1. The correct answer is A. Beautiful. Moving on to question 6, let's see if Decisive Unicorn is still in the lead. Congratulations, Decisive Unicorn. Moving on from question 5 to question 6. All right. Choice A, the correct answer. All right. So moving on to question 6. All right. Yeah, we can leave it at that. So this is a typical answer reason type of multiple choice question. So notice that you've got yes, yes, and no, no. So we've got our answer, yes, and then we've got a because. So we've got an answer and a reason. Now, you might be inclined to solve it this way. Force of gravity equals mass times the acceleration due to gravity. Mass is an intrinsic property of matter, so your mass is unchanged. The magnitude of the gravitational field, little g, is unchanged. Therefore, your force of gravity or weight is unchanged. That would give you answer choice D. Unfortunately, that is incorrect. Class, what is wrong with what we just said? All right. So this is interesting. We got some interesting things. Okay, so sure, the mass is the same. The question is asking about weight, but that doesn't answer the question, right? So what is wrong with our question? Or what is wrong with the solution we have right there? I agree, weight isn't the same as mass, but like what's wrong with this solution right here? There's an incorrect statement. Okay, we've got this one. Weight changes, mass doesn't change. But that doesn't answer my question. That doesn't answer what is wrong with this. All right. Okay. I like this one. Uh, G, the acceleration of gravity is changing depending on how close you are to the core. Sure. Right? So the force of gravity changes. The magnitude of the acceleration of gravity is slightly changed. We have to use a different formula for the force of gravity. These are all correct answers. Okay, so let's take a look. So it's this statement right here, the magnitude of the gravitational field, little g, is unchanged. Technically, you can use this if you change the gravitational field. It's not good to use this equation in this particular case, but so let's walk our way through it. So the magnitude of the gravitational field is not the same on the surface of the planet as it is high above the surface of the planet. Okay. So, yes, we typically consider the gravitational field to be constant near the surface of a planet. However, in this question, it says high above the surface of the planet. That is not near the surface of the planet. So, from your physics experiences, or you should know, or at least learn today, that the magnitude of the gravitational field decreases with distance from the planet. So the correct answer is A. Okay. So in terms of equations, you need to use this equation. Newton's universal law of gravitation, the force of gravity equals big G, the gravitational constant times mass 1 times mass 2 divided by r squared, where r is the distance between the centers of mass of the two objects. So for this particular case, that's going to be the the universal gravitational constant times the mass of the Earth times the mass of the object divided by the radius of the Earth plus the altitude to the object, that quantity squared. So on the surface of the planet, your altitude is roughly equal to 0. High above the surface of the planet, the altitude is going to be much, much greater than 0. Therefore, you weigh less high above the surface of the planet. It's a true statement. You weigh less when you are high above the surface of the planet. If you're curious about how much less, I do actually provided all the calculations in my Ultimate Exam Slayer. They're pretty long. They look like this. So So I'm not going to walk through that today, but you are more than welcome to to look through that if you get my ultimate exams later. Okay, so I do want to get back to the answer reason multiple choice type of this, because I think it's important to recognize that the reasons for answers choice A and B are both correct statements. It is correct that you are farther from the center of the planet when you are high above the surface of the planet, and it is also correct that mass is an intrinsic property of matter. Those are both true statements. But the because makes it so that answer choice B is incorrect. So your weight is different when you are at rest on the surface of the planet than when you are high above the surface of the planet, but not because mass is an intrinsic property of matter, but rather because you are farther from the center of the planet. So be very careful of that. You might run into reason answers that are true statements, but don't fit the question correctly. So just be very careful of that. Beautiful. Moving on to question 7. Let's see if Decisive Unicorn is still in the lead. Decisive Unicorn. Oh, I believe you're losing. Somebody's getting Rocky Hummingbird is catching up. I don't know. We'll see. All right. Moving on from question 6 to question 7. Looks like we'll be good there. And next. All right. Answer choice B is correct. But before we move on, I want to talk about this. I've taught this class for a really long time, roughly 2.5 decades. And it can be a very difficult class. And students can struggle. I'm going to be honest. But it's because it's a combination of science and math, right? And you're just not used to that. So this idea that you feel cooked and that you look at this and you don't understand the words, you need to keep working at it. And eventually it will get better. And I will tell you from experience of teaching this class for a really long time that it just takes time. And you got to put time and effort into it. I'm glad you're here. And I'm going to walk my way through why these are correct. But I do feel you, and I do understand that it can be difficult at times. Just know that. All right, here we go. Coming back here, moving forward to question 7. Okay, so you are in a car, question 7. Okay, so choice A. Your body does not accelerate forward. This is a very important thing to recognize. Choice A is incorrect, okay? So your body does not accelerate forward. The car is slowing down. The car is accelerating backward, which makes you feel like you're accelerating forward, but your body just keeps moving forward. Your body is actually accelerating backward just slightly less than the car. So realize your body does not accelerate forward. Choice B. Your body is an object in motion which maintains a constant velocity unless acted upon by a net external force, Newton's first law. Yes, your body's inertia tried to keep your body moving forward while the car slowed down. So as the car slows down, you move faster than the car until you collide with the seatbelt. So choice B is correct. Choice C. An object in motion continues in motion unless acted upon by an external force is incorrect, right? So this is taking Newton's first law and not saying it correctly, right? An object in motion continues at a constant velocity unless acted upon by a net external force, right? So those are two different things. Also, inertia itself provides the forward force is incorrect. Inertia is not a force. So choice C is incorrect. Choice D, net external force of inertia, just doesn't make any sense. Inertia is still not a force. Producing the forward acceleration of your body does not accelerate forward. So choice D is incorrect. All right, moving on to question 8. Let's see if Decisive Unicorn pulled ahead, I think, a little bit there. All right, so moving from question 7 to question 8. So there is a graph. There we go. All right, so we've got choice D as the correct answer. Let's walk our way through it. All right, so I need to move this over so we can get both on there. Okay, so question 8. The first thing to notice is this is not a graph of spring force versus displacement from equilibrium position, right? This is what the AP exam often does. They take something you are familiar with and present it slightly differently. So you would expect this to be a spring force versus displacement from equilibrium position graph, but that's not quite what it is. It's very close. So we know when the mass is hanging at rest, on the elongated vertical spring that the spring force is up and the force of gravity is down. So we can sum the forces in the y direction. We get force of in the y direction, net force in the y direction equals the force of spring minus force of gravity, which equals mass times acceleration in the y direction. Again, the acceleration in the y direction equals 0. Therefore, we get the force of the spring equals the force of gravity. So we can substitute the magnitudes of those equations. The spring constant times the displacement from equilibrium position equals the mass of the object times the acceleration due to gravity. So from the graph, mass is on the vertical axis. Spring length, which is a distance, is on the horizontal axis. So mass times the acceleration due to gravity equals the spring constant times x. We've got that right here, displacement from equilibrium position. Therefore, we can solve for the mass. The mass equals the spring constant divided by the acceleration due to gravity times x. So we have an equation for the slope-intercept form of a line. Y equals slope times x plus b. Notice I've replaced the m in y equals mx plus b with slope. That is to not have the confusion here between the two m's. This m here stands for mass, and I'm going to use slope for slope instead of mass. So slope equals the spring constant divided by the acceleration due to gravity. So the spring constant equals the slope times the acceleration due to gravity. So in order to get the spring constant from this graph, we need to multiply the slope of this graph times the acceleration due to gravity. So we need to draw a best fit line and determine the slope of the best fit line and multiply that by 10 newtons per kilogram. All right. So again, we've done this before where we draw a best fit line. You can see we have to pick 2 points again. This point here is 0.28 meters and 1.0 kilograms. And this point right here is 0.1 meters and 0 kilograms. So we can now figure that out. What the slope of this line is, it is going to be 1 kilogram minus 0 kilograms divided by 0.28 meters minus 0.1 meters, or 5.5 repeating kilograms per meter. Again, we figured out the slope, or the spring constant is equal to slope times the acceleration due to gravity. And therefore, we can multiply the 5.5 repeating kilograms per meter times 10 newtons per kilogram. And the kilograms cancel out, and we get roughly 56 newtons per meter. And so the correct answer then is, again, a number that's close to the 56. It's 55. So the correct answer is D. So again, this is one of those where it best approximates. So we got 56, and the correct answer is 55. So that approximates it. So I do have a question, though. Class, what is the natural length of this spring? You should be able to look at the graph and tell me what the natural length of this spring is, class. Correct. It is 0.1 meters. So the natural length of a spring is the length of the spring with 0 force acting on it, or 0 mass hanging from it. So from here, you can see that the natural length of the spring is going to be this 0.1 meters. Beautiful. I think that's all I have to say. Okay, good. I do want to take a moment to look at this question, or this comment. So here, I know this doesn't directly relate to this question, but I would just like to say I find AP Calculus AB way easier than AP Physics 1. It feels it's difficult because it's simply just not pure mathematics. So absolutely. So I hear this often. Okay. So one of the things that I get from my AP Physics, or I'm sorry, my AP Calc students, is that they have learned to do, they've learned to look for patterns. They're pattern recognition. And so you've learned in your AP Calc class to find these patterns, and so you don't fully understand it as well, but you found all these patterns. And in AP Physics, we break all those patterns and make it so that you have to understand everything that's going on, which is exactly what I did with this question. Okay. In this question, I literally gave you a graph that is not one that you would expect, even though it literally looks like a graph that many students would expect to get for a spring force graph, but it's not. And this is what we do. But if you understand the physics and the math, you can walk your way through it. And so this is one of the issues we run into with AP Physics, is that students want to find these patterns and find these the pattern recognition and be able to just like follow specific instructions to be able to solve problems. And it doesn't work that way. You have to understand everything that's going on. And that's why we end up with so many students who struggle near the beginning, because it is a different way of thinking. You have to literally understand everything. And it's what I actually love about physics, because it just helps you understand so much better how everything works in the world. Anyway, I'll move on. Done with question 8. Move on to, actually, hold up. We'll see if Decisive Unicorn is still winning. Oh! Rocky Hummingbird on fire. Uh-oh. Rocky Hummingbird. Okay. Moving from question 8 to question 9. All right, here we go. I think I can zoom in. All right, answer choice C is correct. I want to talk about a couple of comments we got. Why not just say the spring constant equals mass times acceleration due to gravity divided by displacement from equilibrium position? Because that's not always correct. That's not always true. Yes, it was true in this particular case, but it's not always true. So is this an equation on the official sheet? No, because this is only true in specific instances. So we went through and we solved for it. So again, you have to understand what's going on and draw the free body diagram, sum of the forces to solve everything. So no, not on the equation sheet. All right. So question 9. Let's move on to question 9 here. All right. Question 9 did not load. Oh, that's a new one. All right, we'll try again. Hold up, sorry, just a second. Question 9. All right. Great. We have question 9. All right. So question 9. Cube 1, in case 1, the cube is at rest on a horizontal surface. the only force acting on the cube are the downward force of gravity and the upward force normal. So there's no force of friction acting on the cube, right? Because those are the only forces acting on it. Therefore, the magnitude of the force of friction is 0. Case 2, there is a force of friction acting on the cube. So a non-zero force of kinetic friction and acts up and parallel to the incline to balance out the component of the force of gravity parallel to and down the incline, which acts on the cube. So the magnitude of a non-zero value is greater than 0. So the correct answer is C. So yes, sometimes they are as simple as this. Like case 1, there's no friction. Case 2, there is friction. Which one's greater? Case 2. Okay, so please do not second guess yourself if a question seems really easy, because some of the questions are going to be actually relatively easy. Some are going to be very difficult, but some are going to be pretty easy. So just be aware of that. All right, moving on. Oh, hold up. Let's see how we're doing here. Oh, Rocky Hummingbird. All right, moving on to question 10. All right. Answer C is correct. So I got a couple comments I do want to talk about real quick. Mo Cow, I'm glad you got an 8. You got a 5 on AP Physics 1. I'm so glad you used my videos. That's awesome. Thanks for that. This was about the previous question. I made the question harder for myself because I doubted it was that simple. And that's exactly what I'm talking about. So don't doubt yourself. It's some of them are going to be that simple. Don't make the questions harder than they are. And I feel like I don't understand what I feel like I understand what the question is, and then I get it wrong. So absolutely, that's my job to give you questions that you are not going to understand, because that's my job. Because if I gave you questions that you understood, I wouldn't be doing my job. You would just be like, well, I already understand all this stuff, right? So this is learning, getting the questions wrong, and then learning what your mistake was. So please realize that. Failing is learning. Getting the questions wrong is learning. Keep persevering and keep looking at it. I'm doing my best to help you, and please pay attention. And sorry, last one. Yes, I fully understand. Some of you haven't learned this stuff. Circular motion. It's in Unit 2. Some teachers are going to teach it, some aren't. But again, pay attention. But again, pay attention, and this will be helpful. All right, so here we go. Coming back here. And next, question 10. All right, so in question 10, we have two different situations. We have when the ball is at the top of the circle, that's situation 1, and situation 2 when the ball is at the bottom of the circle. So the constant speed of the ball is a variable which connects the two situations, right? Because the ball is moving at the same speed the whole time, both in situation 1 and situation 2. So what we're going to do is we're going to analyze situation 1 to solve for that constant speed of the ball and then use that speed in the second situation, right? So this is a pretty common way of needing to solve questions where you have two different parts and you have something that connects the two. In this particular case, it's the speed of the ball. So for situation 1, well, the knowns are the mass of the ball, the radius of the circle, the force of tension is 3 newtons when it's at the top of the path, and we're looking at the force of tension 2 when it's at the bottom of the path. So situation 1, when the ball is at the top of the path. In our free body diagram, we have the force of gravity, which is down, and the force of tension 1, which is also down. But because it's a circle, we need to recognize that that is in. Right? So we don't, when things are moving in a circle, you need to think about in versus out. And both of these the forces are inward. So in is positive. So it's not that they're down, but rather that they're inward. Therefore, force of tension 1 and force of gravity are both positive when we sum the forces in the in direction. That's equal to mass times the centripetal acceleration. We can substitute mass times the acceleration due to gravity in for the force of gravity, and we can substitute the tangential velocity squared divided by radius for the centripetal acceleration. So we can substitute in all of our numbers and we can solve for this tangential velocity. We get that the tangential velocity equals the square root of 6.4 meters per second. And again, we can now know that constant speed of the ball, which we can switch now to looking at situation 2 and use that in situation 2. So again, we have all of our knowns. But now we also know the tangential speed of the ball. It is the square root of 6.4 meters per second. So situation 2, the ball is at the bottom of the path. So now the force of tension is in the direction of the string, so that's going to be towards the center of the circle, and the force of gravity is still down, right? So realize, again, in is positive, out is negative. So when we sum the forces in the indirection, the force of tension 2 is positive, the force of gravity is negative. Again, force of gravity is negative because it is out. Again, we can substitute in mass times acceleration due to gravity for the force of gravity and tangential velocity squared divided by the radius for the centripetal acceleration. We can solve for the force of tension 2. It equals mass times acceleration due to gravity. We have all of that. And we can substitute in all of our numbers. Now we can substitute in the square root of 6.4, which we're going to square, which just makes that 6.4. And we get 13 newtons. So the correct answer is C. We solved for that force there. Now, I do want to talk about these free body diagrams for a moment. So class, what needs to be fixed between these two free body diagrams? So something needs to be fixed between the two free body diagrams. So My Little Pony, no, where'd you go? All right, I lost it. So force of tension 2 needs to be longer in our free body diagram. We determined that we know that force of tension 1 is 3 newtons and force of tension 2 is 13 newtons. But in our free body diagrams, we've drawn force of tension 1 and force of tension 2 to be the same. So force of tension 2 needs to be much larger than force of tension 1. And yes, it also needs to be larger than the force of gravity. So yeah, and yes, actually, that's a good point as well. There needs to be a net force towards the center. In order for there to be a net force in towards the center, this force of tension 2 needs to be greater than the force of gravity. That's a good point as well. Thank you for that. So we just need to draw this force of tension 2 greater. In fact, it needs to be, it's actually going to look like that, because the force of tension 2 is 4 times, roughly more than 4 times the force of tension 1. Beautiful. And we are done. Actually, no, we're not done because we want to do this. Actually, here, we'll do this. Let's see who won here. Resilient Hamster came in third. Decisive Unicorn. I'm sorry, Decisive Unicorn. You were winning, but Rocky Hummingbird ended up being our winner today. Congratulations, Rocky Hummingbird. Congratulations to all for being here. That's awesome. I had a really good time. So my plan is for this video to remain live on YouTube. It's just going to be exactly what we did here. So this multiple choice quiz is posted in my Ultimate Exam Slayer. In fact, you can already see it's already posted in here, and there are 25 questions. We've only walked through the first 10. But you can have access to those if you purchase my Ultimate Exam Slayer. So Unit 3, as I said before, the multiple choice live YouTube Kahoot will be on Tuesday, December 16 at 7 p.m. Unless, of course, I am in the emergency room. And I will, of course, end by saying thank you very much for learning with me today. I enjoy learning with you. Thank you, everybody. And good night.
Flip.